Hi, I'm Ms Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. Here's an example of a pair of inverse functions. We have the function y equals 2x minus 2. And we have the function y equals 1/2 x plus 1. So, but what we're interested in, of course, is derivatives, right? And what are derivatives? They're the slope of the function. And so notice that in the function in orange here, y equals 2x minus 2, since it's linear, we know the slope is the same everywhere, and that slope is 2. And then in the blue function, we have a slope of 1/2. They're reciprocals of each other, which makes sense. Derivatives are a ratio, the change in y over the change in x. They're a fraction, right? If the slope of the original function is dy over x, and then we switch all the x's and y's, what happens? We flip or get the reciprocal of the fraction. In general, it's actually true that the derivative of the original function, if you flip it, you get the derivative of the inverse function. But it of course gets a little more complicated when you have a function that's not just a straight line. So let's consider the general case. You have the function on the left in blue, and then you have its inverse function in orange on the right there. And we're talking about switching all the x's and y's. So if the function on the left goes through the point AB, then the function on the right goes through the point BA. So that's just your basic definition of inverse functions. So now let's talk about the relationship between the slopes, but instead of thinking of it as the Leibniz notation dy dx and dx dy, we're going to use this function notation and see what happens. Our goal is to be able to find the slope. So we're asking ourselves for a formula, or what is the slope of f inverse? Well, the slope of f inverse is the derivative of f inverse. How do you denote that? You would say f inverse prime, which is in the green box here. And if we want to evaluate it at the point B, if we want to know the slope of the tangent line at the point B, we would say f inverse prime parenthesis B. So this is the slope of f inverse at B. Now we know that that slope is going to be the reciprocal of the slope of the original function at the point A, right? Because the x's and y's are flipped. So here we have the reciprocal of the slope of the original function, but notice that we have to write at A because the x and y coordinates have been flipped. A is the y coordinate of the inverse function. So another way of writing A is f inverse of B. That's what it says right here. So instead of writing the formula as I have it written right here, f inverse prime of B equals 1 over f prime of A, we just replace the A with f inverse of B, and you get it as it's written here in yellow. Okay, so let's go ahead and use this idea that the derivative of the inverse is the reciprocal of the derivative of the original function, which is what we're going to do in the next video. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.